I'll work based on the assumption that you already have some background knowledge on trigonometry. And you must have dealt with trigonometry in your grades 8 and 9. Alright, so we are just going to build on the things that you should have learned in those grades. That's what it's going to be. Secondly, this comes with a note which requires the download, and see the video and the class notes are to work hand in hand. You see, because there are certain things you will find in the class notes that is not in this video, but this video is to give you the basics and the explanation on the things you will come across in the class notes. So I want you to ensure that you download the class notes and read through that as well. That if you combine the efforts in this video with the class notes, then you will become quite confident in dealing with any question or any problem that may crop up on trigonometry. So let's just get right into it. We are going to start with a definition of term, trigonometry. Now, I once had a student who was put off by the name and says that the name is kind of too big, and it just, to her, it just implied that it's going to be a very difficult topic. But that is not true. Trigonometry is fairly easy once you get a hang of it, and I'm hoping that this video will help you to be able to do that. Okay, so what is trigonometry? Trigonometry is the branch of mathematics that deals with the relationship between the sides and angles of a triangle. So anytime you hear trigonometry, think triangle. Okay, think triangle. The study of how angles and sides affect each other basically is what's referred to as trigonometry. And angles are easy, and of course triangles too. There are things that you have dealt with earlier than now. I'm sure that by now you already know the differences between the acute angle, the obtuse angle, the reflex angle, and the right angle. And then you are also very familiar with the properties of the different kind of triangles: the scalene triangle, the isosceles triangle, the equilateral triangle, and the right angle triangle. All right. Our focus first will be on the right angle triangle. Okay, that's what we're going to be dealing with first. And we're going to start with trigonometric ratios. Now, trigonometric ratios are entirely focused on a right angle triangle. So that we just don't assume. What is a right angle triangle? A right angle triangle is a triangle in which one of the angles is a right angle. That is, one of the angles is 90 degrees. All right, and this is very easy to see. Okay, 90 degree or right angle is the angle between the vertical and the horizontal. So if you're standing upright on the ground, for example, you will be making an angle 90 degree with the ground. Your height will be the vertical, and then the ground will be the horizontal. Okay, the angle between the vertical and the horizontal is angle 90 degrees. Now, I'm sure you are aware that every triangle has 3 angles inside, and that these 3 angles sum up to 180 degrees, 180 degrees. And so when one triangle has one of those 3 angles to be 90 degrees, then that is a right angle triangle. Okay, it has nothing to do with the position of the angle. It's not because the angle is on the right side or on the left side or whatever the case may be. I once heard somebody say that. All right, but right angle triangle is that triangle where there is a 90 degrees inside that triangle. Now, there are 3 sides to a right angle triangle, as well there are to every other triangle. Every triangle has 3 sides, but for a right angle triangle, there are specific names given to each of the sides, which is very important in calculation. Okay, so the first side that I'm going to talk about is what is called the hypotenuse side of the right angle triangle. And the hypotenuse side is the side which is opposite the right angle. It's usually the longest side of the right angle triangle. And you see, to locate the hypotenuse side is very easy. All you need to do is to find the right angle, which once again is the angle between the vertical and the horizontal, which is 90 degrees. At the moment you locate that, just look in the opposite direction and then you have your hypotenuse side. Okay, and another tip is that the hypotenuse side is the only line in the right angle triangle which where the two vertices that it formed, none of them carry the right angle. Okay, so you will see on this end of the hypotenuse and on that end of the hypotenuse, the 90 degrees is not there. Okay, the next one is the opposite side of the right angle triangle. The opposite is the side that is opposite the angle in question. Now, we said trigonometry is the relationship between angles and sides. So if you're talking about trigonometric ratios in a right angle triangle, then obviously there must be an angle we're talking about, and that angle is called the angle in question, or the angle under consideration. And it is by that angle that you determine which side is the opposite. So the moment you can locate that angle within the right angle triangle, you just need to look in the opposite direction and then you have your opposite. Okay, that should be fairly easy as well. And then the last side of the right angle triangle is the adjacent side. And the adjacent side is the side that lies between the angle in question and the right angle. So your adjacent side always carries two angles. You have the right angle on the adjacent side, and then you also have the angle being considered lying on the adjacent side as well. So now this is a picture of that. Okay, you have the hypotenuse side. You can see that it is directly across the right angle, and then you have the opposite side, which of course is also directly across the angle being considered. The angle in question in this diagram is the angle theta, and opposite it you have the opposite side. And then the adjacent side, you have both the right angle and the angle being considered lying on that line, and that makes it the adjacent side. Okay, now this is really very important to be able to, separate these from that. Okay, because if you are not able to get the sides correctly, then your trigonometric ratios will be wrong. Now, what we are about to do is to find the relationship between this angle theta and the sides of this right angle triangle. That's basically what trigonometry is about. That if you had an angle inside a right angle triangle, or inside a triangle as a matter of fact, how does it relate with the sides of that triangle? And the first thing I want to think about is, what would be the sine of this angle theta if I wanted to find the sine? So the sine of that angle is equal to the length of the opposite side divided by the length of the hypotenuse side. That is, sine theta is equal to opposite divided by hypotenuse. It means that if I used my four-figure table to find the sine of that angle right there, it will give me the exact same value as I would have if I divided the opposite side by the hypotenuse side. Okay? Now, what if I want to find the cosine of that angle? The cosine of theta is equal to the length of the adjacent side divided by the length of the hypotenuse side. Okay, so it means that if I divide the adjacent side by the hypotenuse side, it will give me the exact same value as if I used my four-figure table to find the cosine of the angle inside the right angle triangle. Please don't forget, you have to get the sides correctly for the trigonometric ratios to work. And it's also possible for me to want to find the tangent of that angle, and the tangent of the angle is equal to the length of the opposite side divided by the length of the adjacent side. It means that tangent of theta would be equal to opposite divided by adjacent. All right, and I'll get the same value from there. So basically, the things I've said so far is that sine theta is equal to opposite over hypotenuse, and that cos theta is equal to adjacent over hypotenuse, and that tan theta is equal to opposite over adjacent. And there is a mnemonic that is being used to, that is being used to remember these trigonometric ratios, and I'm sure you must have heard it before, and that is SOHCAHTOA. SOHCAHTOA spells sine of an angle is equal to the opposite side divided by the hypotenuse side. That's what forms the SO. Then you have the cosine of an angle is equal to the adjacent side divided by the hypotenuse side. That's what forms the CAH. And then the tangent of an angle is equal to the opposite side divided by the adjacent side, and that's what forms the TOA. So if you remember that, it will help you to use the trigonometric ratios correctly whenever you are required to use them. Please don't forget that this is only applicable for a right angled triangle. Now let's look at maybe an example or so on this before we move on from there. Example. Now we have this right angled triangle, and I know that it's right angled because there is a right angle inside the triangle. You can see that there is an angle between the vertical line that is 10 meters and the horizontal line that is like the floor or base of the right angle triangle. Okay, so this is a right angle triangle, and we have to solve for the missing length r that has been highlighted. We have to solve for r. Now, first thing we need to think about is what sides of the triangle are we trying to find, and what side of the triangle do we have? And of course, we'll consider the angle that is inside the triangle. Of course, the angle is 20 degrees. That's the angle we are considering. And the vertical line is 10 meters. And if you remember what we said about the opposite side of a right angle triangle, we said it is the side that is directly across the angle being considered. So it means that 10 meters will be the opposite, and then r will be the because that is the side that is directly across the right angle. Okay, that's facing the right angle. So our solution, our opposite is 10 meters, our hypotenuse is r, and our theta is equal to 20 degrees. Okay, so which trigonometric function combines opposite and hypotenuse? That would be sine. The SO part of the SOHCAHTOA. So sine theta is equal to opposite divided by the hypotenuse. So basically we insert the values. That would be sine 20 degrees is equal to 10, which is the opposite, over r, which is the hypotenuse, and then we cross multiply. So you have r times sine 20 is equal to 10, and then we divide both sides by sine 20 degrees, and you have r equals to 10 divided by sine 20 degrees, and your final answer, if you press your calculator, your r will be equal to 29.24 meters. And this is really very easy. Trigonometric ratios don't get more complex than this. Once you have the right angle triangle, all you need to do is to locate which sides of the triangle you're given and which side you're trying to find, and then you determine from your trigonometric ratio which of those trigonometric functions will work. And the moment you're able to find that, then you insert the values and you press your calculator, you get your answer. It's easy peasy. So, but we'll move a little bit away from here to another important part of trigonometry. I'm sure you must have heard it before as well, and that is Pythagoras' theorem. Now, many of you have heard the name before, but some of you may not be able to state the Pythagoras theorem. So we're going to start with that. Pythagoras theorem states that in a right angled triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. And notice it says in a right angle triangle. It means that Pythagoras theorem only works in a right angle triangle, just like your SOHCAHTOA. It only works in a right angle. Okay, but if you have a right angle triangle, if you have a right angle triangle, then the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So hypotenuse squared will be equal to your perpendicular line, which you could call the opposite side, squared, plus the base, which you could also call the adjacent side, squared. Okay, the reason why many times Pythagoras theorem uses perpendicular and base is because there is no included angle. There is no angle under consideration, which means that any side could be opposite and any side could be adjacent. But it wouldn't matter which side you pick as opposite and adjacent. When you're using Pythagoras theorem, you'll get exactly the same answer. But once an angle is indicated, the angle is the one that fixes the side that is the opposite or the adjacent. Okay, so you could put that like that. So let's look at an example or two of cases where we had to use Pythagoras theorem. Now we have this right angle triangle, and this right angle triangle has two sides given to us, and we are supposed to find the third side. The perpendicular side, which is the vertical, is 15 centimeters, and then the base, which is the horizontal side, is b centimeters, whereas the hypotenuse is always hypotenuse, that is 17 centimeters, is the side, don't forget, that faces the right angle. Okay, so we can put that out, the solution. We use Pythagoras theorem. Perpendicular side squared plus base squared would give us hypotenuse squared. And if we insert those values, it means 15 squared plus b squared will give us 17 squared. 15 squared is 225. We add b squared to that, and that will give us 17 squared, which is 289. And then we subtract 225 from both sides. So we have b squared equals to 289 minus 225. And then our b squared will be equal to 64. And we find the square root of both sides. And obviously our b would be equal to 8. Our b is equal to 8. And of course the unit is centimeters, so you just add that to it. 8 centimeters. Okay. So that's quite easy. Let's see another question on Pythagoras theorem. Now, this question says we are given a square, and a side of the square is 4 centimeters long, and it says we have to find the length of the diagonal. Now, there are two things that we are being tested on here. Number one is that we must know the properties of a square. It says, because we're only given 4 centimeters for a single side, but we know, according to the properties of a square, that a square has the same length all round. So it means that if one side of the square is 4 centimeters, it means that the other sides will be 4 centimeters each. And then it says we should find the length of the diagonal. What's a diagonal? A diagonal is a line that is drawn from one vertex to the opposite vertex, and usually it divides the square into two congruent triangles. Congruent means things that are the same, that are equal. Okay, so now we can use knowledge then to since a side of the square is 4 centimeters, we can use that to generate our square. Because all sides are equal, so it means that we have a square that is 4 centimeters by 4 centimeters. Okay, and we label our square to be A, B, C, D. Then we draw a diagonal from A to C, a line from one vertex to the opposite vertex. And if you look at this diagram on your screen, you'll realize that there are two right angle triangles formed. And these two right angle triangles are congruent. That is, they are basically the same. Okay? So we're gonna use the first one, that is triangle ABC, but you could use any one you prefer. You could use ACD if you like, but I'm going to be using triangle ABC. The right angle is at B. You can see that the angle between the vertical and the horizontal. Okay, so but since there is no angle inside, someone may wonder, why don't we use our SOHCAHTOA? The reason is because there is no angle inside. There's no angle in question, no angle in use. Okay, of course, if we wanted to, we could use SOHCAHTOA. We could go, but it's a long process, and there would be no point to it, as a matter of fact. So I'll just move on from there. So I'll use Pythagoras theorem. It says that the square of the diagonal plus the square of the base is equal to the square of the hypotenuse. So inside values, diagonal is 4, the base is 4. So you have 4 squared plus 4 squared equal to AC squared. The square of 4 is 16, so you have 16 plus 16 is equal to AC squared. That means 32 will be equal to AC squared. You find the square root of both sides. AC will be equal to 4 root 2. Now, if you use the calculator, of course, your calculator will give you answer in decimals. But I used Sodic. This is in Sodic form, okay? But any one of those two will be correct. So the length of the diagonal of this square, excuse me, is 4 root 2. All right, and Pythagoras theorem does not get more complex than this. There is nothing that you know. The moment you can see your right angle triangle, you look at the sides you're given, you insert. Any point in time when you see a right angle triangle, always think Pythagoras theorem or trigonometric ratios. Now we look at trigonometric ratios of special angles. Now there are certain angles that are referred to as special angles, and the reason is because they have relatively neat trigonometric values. Your angle 0, your 30 degrees, your 45 degrees, 60 degrees and 90 degrees, they are called special angles because their trigonometric ratios are kind of easy to determine, and you will be required to memorize them. Okay, don't think of it as something that is difficult or that is a big deal. It's not. It's fair. It's quite easy, to do. All right. So now the next thing I'll do is to give you a table in this video. I'll give you a table of all the trigonometric ratios of these special angles, so that if you would like to memorize them, you have what to work with. So here's the table. You can see the angles ranging from 0 degrees to 90 degrees. You have 0 degree, you have 30 degrees, you have 45 degrees, you have 60 degrees and 90 degrees. And then you have your trigonometric ratios ranging from sine of the angle to the cosine of the angle to the tangent of the angle. Those three are quite familiar. Then you have the cosec of that angle, that is the cosecant of that angle, and you get the cosecant of an angle by finding the inverse of the sine of that angle. So cosec theta would be 1 divided by sine theta. You see, that's the reason why if you look at sine 0 degree, the answer is 0, and then you look at cosec 0 degree, it is undefined because 1 divided by 0 will give you undefined. Okay, cosecant of an angle is the reciprocal of the sine of that angle. In the same vein, you have secant of theta, which is the reciprocal of the cosine of that angle. So sec theta would be equal to 1 over cos theta. So when cos 30 degree is root 3 over 2, you realize that sec 30 degree is 2 over root 3, because that's basically an inverse of whatever you have up there. And then cotangent. The cotangent of an angle is the reciprocal of the tangent of that angle. So will give you cos theta. Now, things I want to mention here before I proceed. And the first thing is that if you go through your class notes, you would realize that you might really not need to cram or memorize this table, because there is a very easy way to determine the trigonometric ratio of special angles that I laid out there using your left finger, your left hand, the fingers of your left hand. All right, and it is very, very easy. So I'll suggest that you pay special attention to that when you are studying your class notes, so that you will be able to do that. You don't have to cram this entire table, because for some people that might be a daunting task. But if you know how to get it using your left hand, then that makes the whole work easy. And then secondly, for those of you who would like to really cram the table or memorize what's in it, now you don't have to memorize every single thing on this table. As a matter of fact, only the first two trigonometric ratios are, if you are going to have to memorize anything at all, it should not be beyond the sine of those angles and the cosine of those angles. And I'll tell you why. The moment you know the sine of an angle and the cosine of that angle, then the tangent of that angle will be the division of the sine by the cosine of that angle. Okay, so tan theta is actually equal to sine theta divided by cos theta. Okay, so if you have sine 0 degree to be 0, and you have cos 0 degree to be 1, then tan 0 degree will be 0, because 0 divided by 1 will give you 0. Do you understand that? Okay, so once you know the values for the sine and the values for the cosine of all these special angles, then you can divide the sine of that angle by the cosine of that angle to get the tangent of that angle. And of course, the remaining three are basically reciprocals. Okay, so to get the cosec of the angle, just divide 1 by the sine of that angle. To get the secant of the angle, divide the cosine of the angle, divide 1 rather by the cosine of the angle. And to get the cotangent of an angle, divide 1 by the tangent of that angle. Okay, and if you also know about complementary angles, then you would realize that on this table you don't need to memorize anything. Okay, you can actually generate them anytime you need them, but we are going to move away from that. Okay, let's look at examples where we have to use our knowledge of the trigonometric ratios of special angles. Okay, example gives us this to evaluate 2 sine 30 degrees plus 3 cos 60 degrees minus 3 tan 45 degrees. Now from our table we can see that sine 30 degrees is 1 over 2 and cos 60 degrees is also 1 over 2. And that's not strange, because 30 degrees and 60 degrees are complementary angles. So the sine of 30 will be the same as the cosine of 60. As a matter of fact, the word cosine comes from the complement of the sine. Okay, so we insert these values. The tangent of 45 is 1. So we insert the values. I have 2 times 1 over 2, which is the sine of 30 degrees, plus 3 times 1 over 2, which is the cosine of 60 degrees, minus 3 times 1, which is the tangent of 45 degrees. Now, if you multiply out, 2 times 1 over 2 will give you 1, plus 3 times 1 over 2 will give you 3 over 2, and then 3 times 1 will give you 3. So you have that, you perform your addition and subtraction operations, and you will get minus 1.2, and that is the answer. Okay, so you see, it's very easy the moment you know the trigonometric ratio of these special angles, and most of the time these are the angles that we have to deal with most of the time. Okay, so let's go to another one. We have another example here. It says 3 into bracket cos 30 degrees squared plus 2 into bracket sine 30 degrees squared. Now, obviously, cos 30 degrees, according to our table, is root 3 over 2, and sine 30 degrees is 1 over 2. So we insert the values. You have 3 times the square of root 3 over 2 plus 2 times the square of 1 over 2. If you perform that, you have 3 times the square of root 3 will be 3, and the square of 2 will be 4, plus 2 times the square of 1 will be 1, and the square of 2 will be 4. Then we perform our multiplication before addition. So multiplication, we have 3 times 3, 9 over 4, and then 2 times 1, that's 2 over 4. You add this together and you get 11 over 4. This is really very easy. Okay, the moment you know the trigonometric ratio of special angles, which itself is very easy, then you can insert at any point in time that you are required to do. Okay, so let's move on to the applications of trigonometry. Now, trigonometry is not just one fancy word that mathematicians came up with so that they could just trouble you. It's useful in our daily experiences, and one of the applications of trigonometry that is really very useful, though many people are not aware of it, is what we're going to be talking about first, which is the angles of elevation and depression. This is really very important. Okay, and this happens virtually every day. Okay, virtually every day. Let's move on. The angle of elevation is the angle between a horizontal line from the observer and the line of sight to an object that is above the horizontal line. Basically, what we're saying is that every look up at an object, you are creating an angle of elevation. Can you see how many times this is applicable? Okay, every single time that you look up or elevate your face to see something, an angle of elevation is created. And notice that the angle of elevation is always above the horizontal line. Okay, so the horizontal line is the way you look normally if you were looking straight in front of you, you're horizontal. But then by lifting up your face, you create an angle that is called the angle of elevation, and it is always above the horizontal line. What about the angle of depression? The angle of depression is the angle between the horizontal line from the observer and the line of sight to an object below the horizontal line. So every time you look down at something, you're creating an angle of depression. It's really important for you to know the difference between the two of them. Every time you're looking down at something, you're creating an angle of depression, and that angle is always below the horizontal line. So you look up at something, you create angle of elevation. You look down at something, you create angle of depression. Okay, angle of elevation is always above the horizontal line because you have to lift up your face. And angle of depression is always below the horizontal line because you have to look down. This is really very important. Now imagine that you have a friend at the top of a building and you are at the base of that building, and then you look up at that friend. Now, of course, you are aware that you have just created an angle of elevation. But for your friend to be able to see you as well, he has to also look down at you. So he also is creating an angle of depression. But the kicker here is that the angle with which you look up will be the exact same angle with which he will look down for you to be able to see each other eye to eye. What am I trying to say? The angle of elevation and the angle of depression are the same thing. They are congruent. The angle through which you look up at something is the angle through which that thing looks down at you. Okay, so if you look at this diagram on your screen, you see the angle of depression created by the person at the higher position, and the angle of elevation created by the person at the lower position. And you can see that those two angles are alternate. And alternate angles are equal. You know, you can see that letter Z, and the angle inside here, depression, is the same as the angle inside here, elevation. All right, now if we step a little bit forward from there, it's important to note that anytime you are required to solve questions on angles of elevation and depression, the sketch of the problem will always be a right angle triangle. This is really very important. You see, the moment you see a question and it talks about the angle of elevation or it talks about the angle of depression, and sometimes they are combined, but the moment you realize it is angle of elevation and depression, then you must know that you will be required to sketch a right angled triangle. So all you need to do is just to follow the question and be able to draw your sketch, but it has to turn out to be a right angled triangle. And of course, you know about right angle triangles that they are solved either by Pythagoras theorem or by trigonometric ratios. So this is very easy. The moment I see a question on angles of elevation and depression, I know that I am to form a right angle triangle. And the moment I am able to form that triangle, I know that I'll either use Pythagoras theorem or trigonometric ratio, that is my SOHCAHTOA, to solve the problem. And that makes it quite easy. So let's look at an example. In this example, it says that there is a cliff, a vertical cliff that is 40 meters tall, and perhaps someone is at the top of that cliff who's looking down at an object on the floor, okay, at an angle of depression of 34 degrees. But it's also important to note that the object is at the same base level with the foot of the cliff. So perhaps both of them are on the floor. The cliff is standing on the ground and the object is on the ground, some distance away from the foot of the cliff. And then someone at the top of the cliff, perhaps the stuff fell from that person, and then is looking down at that object, and the object and the angle of depression created is 34 degrees. Okay, so we will try to sketch our diagram, but then let's call the distance between the object and the base of the cliff, let's call that x. Okay, then we'll try to draw our diagram. Now, this is a sketch of this problem. We have a cliff that is 40 meters high, and someone is at the top of the cliff, that is at O, who is the observer, and is looking down at an object, and we represent the object with P. is looking down at the object, and it created an angle of depression of 34 degrees. You can see that angle of depression marked with red. Okay, the angle below the horizontal is 34 degrees. And now we are required to find the distance between the object P and the foot of the cliff A, which we are representing with X right now. Now we have a right angle triangle, don't we? And in this right angle triangle, we have the adjacent, the opposite, and the hypotenuse. So let's see the sides that we have. The line OA, which is the height of the cliff, that would be our opposite. Why? Because that is the side that is facing the angle being considered. Now, how did the angle being considered 34? How did it get inside the right angle triangle? Because you remember, they gave us the angle of depression, which is 34, and it's outside. But because the angle of depression is the same value as the angle of elevation, we can simply call the angle of elevation 34. Okay, they are alternate angles. You can see that Z right there, and that makes this 34. Okay, so the side facing that angle 34, that's the opposite side, and we are required to find the adjacent, which is the distance between the object and the foot of the cliff. Okay, so from the triangle you have that, and the trigonometric ratio that combines opposite and adjacent, that's your tan. That's from your TOA. Opposite divided by adjacent will give you the tangent of that angle. So we insert values. The tangent of 34 degrees will be equal to opposite, which is 40, divided by adjacent, which is x. And then from here we can cross multiply, or multiply both sides by x if you prefer. Okay, so we can do that. And then on the left hand side we have x tan 34, which will be equal to, of course, on the right hand side we have 40 alone. And then we divide both sides by tan 34. Oh no, let's find the value of tan 34. That will be 0.6745. Okay, so we have 0.6745 multiplied by x, which is equal to 40. We divide both sides by that, and then we have x on this side to be equal to 59.30. So the value of x is 59.30, and of course it's in meters, so we add meters to that, and that gives us the answer. See, this is quite easy. The moment you follow the question, you sketch your right angle triangle, then you insert your trigonometric ratios excuse me, and then you get your answer. It is very, very easy. Another example, and in this particular example there is a little bit of a difference from the other one, not only because we are dealing with the angle of elevation, but also because there is a man who's looking up. The angle of elevation is being created by a man who is 2 meters tall. Okay, so we are not going to draw the line of sight to the top of the tree from the foot of the man, which would have been the floor or the ground. We're going to draw it 2 meters above the ground, because the man is seen with his eyes, and that is 2 meters above the ground. Okay, so our solution, we will let the height of the tree be h, and then we'll try to sketch the section. And this is what it looks like. On the left hand side you have the man, he's 2 meters tall, and on the right hand side you have the tree, which is h meters tall. Now the man from his eyes, which is not on the ground, remember, creates an angle of elevation of 28 degrees. It is important that you don't draw the line for the angle of elevation from the ground, because the man cannot see with his legs. It is from his high level, which is 2 meters above the ground. So the man looks up and creates an angle of 28 degrees, and the distance between the man and the tree is 30 meters, like you have in the diagram. Okay, then we have a right angle triangle formed. The base or the adjacent of the right angle triangle will be 30 meters. You can see that there are 2 angles on that side, so that's the adjacent, which is 30 meters. But then we have to find the opposite side, which will not be h, because h is the height of the tree. That will start from the top of the tree to the bottom of the tree. But the right angle triangle starts 2 meters before the bottom of the tree. Do you understand what I'm trying to say? Okay, so the height, the adjacent that we will use will be h minus 2, because h is the total height. We remove 2 from it, and then that gives us the opposite side of the right angle triangle. It is opposite because, of course, it is the side that is facing the angle 28 degrees. So from the right angle triangle, adjacent is 30 meters, opposite is h minus 2, and of course the angle theta is 28 degrees. Which trigonometric ratio combines, trigonometric function combines your opposite and your adjacent? Once again, your TOA. So you have tan of that angle is equal to opposite, which is h minus 2, divided by adjacent, which is 30. We cross multiply here, you have h minus 2 is equal to 30 times tan 28, and from here you can just solve it. You can find 30 tan 28 degrees, and then you move 2 to the other side and add to the answer. And I'm just going to do all of that together. So final answer, h will be equal to 17.951. If you had your 30 tan 28 degrees, you would have gotten 15.951. So you move 2 to the other side, and that gives you 17.951. So it means that the distance, or the height of the tree rather, is approximately 17.95 meters. That's correcting it to 2 decimal places. So you can see how easy it is to answer questions on either angle of elevation or angle of depression, and there is no way to make the questions more complex or complicated. You are going to form right angle triangles, and then you use your SOHCAHTOA or Pythagoras theorem to get the answer that is required of you. Alright, so now I am going to stop the video here, even though we are not done with trigonometry, so you can just call this part 1. Because there are other applications of trigonometry that we are also going to talk about, and a few other things that we are going to talk about. But I do not want the video to be too lengthy, so that you can spend some time to understand these concepts here and then revert to your class notes. There are examples, other examples, there are exercises which you are to do and get across to me, so I can assess how well you have understood the concept. And if you have any question, all right, I want you to write them down so that we can treat them in our interactive session. Okay, by the time we are having an interactive class, you'll be able to ask your questions, and you can be certain that you would receive answers to all of those questions. Okay, so that's the end of it. Thank you very much for your time today, and I'm going to see you in the second part of this video on trigonometry.